10th in 2005, space experts found a Jupiter-sized exoplanet, HD 189733b, with an unmistakable Earth-like blue tint 63 light-years away. Notwithstanding, in contrast to Earth, HD 189733b was not blue in view of its oceans and seas. Rather, the shading originated from its silicate-rich clouds. HD 189733b is likewise dangerous. The primary issue is the 8,700 km/h (5,400 mph) winds that blow over the exoplanet. That is multiple times the speed of sound, which is madly quick. For correlation, top-supported breezes of the infamous Hurricane Katrina blew at 280 km for each hour, 175 mph. Then there is the downpour. The silicate-rich billows of HD 189733b reason downpour of liquid glass to tumble from the skies. That downpour doesn't fall straight down as a result of the superfast winds we just discussed. Rather, this odd precipitation falls sideways. Even in the event that we by one way or another discovered our way around that, we would at present need to manage the high temperatures on the exoplanet. HD 189733b is so near its star that it is strangely hot. To place that in better point of view, it is so close to its Sun that HD 189733b finishes an upset around its star in simply 2.2 Earth days. Curiously, a day on this exoplanet is additionally 2.2 Earth days long. The gravitational cooperation between a planet and its star can make a planet have a day and year of a similar length if the planet turns out to be tidally bolted to its star, similarly as our Moon is tidally bolted to the Earth. This implies the planet turns on its hub in a similar measure of time that it takes to finish one upheaval around its star. Pivots cause days and evenings, and insurgencies cause years. A tidally bolted planet consistently keeps a similar side toward its Sun. Thus, one side is sentenced to constant daytime while different has never-ending evening time. Nineth in February 2009, cosmologists working the Convection, Rotation and Planetary Transits (CORO) satellite found another exoplanet in the Monoceros group of stars 480 light-years from Earth. They called it CORO 7b. CORO 7b is a rough, Earth-like exoplanet despite the fact that it used to be a Saturn-sized hot Jupiter, a term used to portray the enormous, gas-filled planets outside our own close planetary system with tight circles around the stars. In spite of having a rough surface that could bolster life, CORO 7b isn't the spot to be. For starters, its environment is loaded up with minerals that structure rock mists. These mists send stones and little shakes tumbling from the skies as though they were downpour. Regardless of whether people figured out how to endure that, they would be demolished by the madly sweltering surface temperature of the exoplanet. Our own Earth is multiple times more remote from our Sun than CORO 7b is from its star. In the daytime, the star in the skies of CORO 7b seems multiple times greater than our own Sun looks from here on Earth. Discussing daytime, CORO 7b may likewise be tidally bolted to its star. A day and a year are simply 20.4 hours long. As you may have speculated, this implies a large portion of the exoplanet for all time faces its star. The surface temperature of that side is between 1980 degrees Celsius (3600 degrees Fahrenheit) and 2300 degrees Celsius (4220 degrees Fahrenheit), which is sufficient to dissolve rock. Cosmologists accept that the stones as an afterthought confronting the Sun are liquid since they can't stay strong at that temperature. 8th exoplanet Kelt 9b is the hottest planet we have ever found. The temperature of its star is around 9700 degrees Celsius (17,500 degrees Fahrenheit), which is almost 2 times the 5480 degrees Celsius (9900 degrees Fahrenheit) surface temperature of our Sun. The daytime temperature on the exoplanet hovers around 4300 degrees Celsius (7800 degrees Fahrenheit), which is still insanely hot. Most stars in the universe do not even come close. As you read this, Kelt 9b is so hot that its hydrogen-rich atmosphere is boiling and escaping into space and right into star Kelt 9, around which the exoplanet rotates. Star Kelt 9 is huge, reaching 3 times the size of our Sun. Exoplanet Kelt 9b is 2 times the size of Jupiter and 3 times heavier. The extreme temperatures are caused by the relatively short distance between Kelt 9 and Kelt 9b. Both are so close that the exoplanet completes an orbit in just 1.5 days. Mercury is 10 times farther from our Sun than Kelt 9b is from Kelt 9. Astronomers believe that exoplanet Kelt 9b will lose its entire atmosphere to star Kelt 9 in just 200 Earth years. By that time, Kelt 9 will have become so big that it could be touching the exoplanet. However, astronomers do not think that the exoplanet will slam into the star. 7th WASP 121b is one weird exoplanet. To begin, it is not spherical but looks more like a football. We mean American football and not the more popular one that Americans call soccer. But the shape is not what makes WASP 121b deadly. Instead, the problem is the exoplanet's nearness to its star. WASP 121b is so close to its star that temperatures hover around 2,540 degrees Celsius (4,600 degrees Fahrenheit). Solid or liquid objects cannot form there, and everything just remains in a gaseous state. This includes its metallic atmosphere, which is filled with iron and magnesium gases. Worse, the exoplanet is losing this atmosphere to its star, just like Kelt 9b. Curiously, the closeness to its star is the same reason that WASP 121b is stretching out of shape. The star is able to exert a heavy gravitational pull on the exoplanet. WASP 121b cannot resist the pull because it has a weak gravitational force. It manages to partly resist, though, causing it to bend out of shape. 6th Upsilon Andromedae b is one strange exoplanet that rotates around the star Upsilon Andromedae A, which is 44 light-years away from Earth. The exoplanet is too close to its Sun, completing an orbit in just 4.6 days. As you may have guessed, this suggests that it is tidally locked, with one side permanently facing the Sun and one unbelievably hot. Interestingly, the hottest area, the warm spot, does not face the star. Instead, it is on the side that never receives sunlight. This discovery puzzled astronomers because the side facing the star should be hotter. Astronomers believe that things are a bit different here because the wind transfers the heated air to the opposite side of the exoplanet. Here is one theory as to how that works. The heat from the star Upsilon Andromedae hits the side of exoplanet Upsilon Andromedae b that is facing the Sun, causing the air to heat up. When that air becomes hot enough, the wind transports it to the opposite end of the exoplanet. At the same time, the wind transports the cooler air at the opposite end to the side facing the Sun. Then the process continues. The continuous switch means that the side shielded from the Sun has a reliable flow of hot air while the side facing the Sun has much cooler air. 5th Ogle 2005b LG390 pound is a rough exoplanet with an exceptionally dainty air found right in the center of our own Milky Way. Each of the 3 components made cosmologists presume that it could contain life when it was found. In any case, they presently accept that it doesn't because of the exoplanet's super low temperature. 6. The surface temperature on OGLE 2005b LG390 pound is near 220 degrees Celsius (364 degrees Fahrenheit), which is too low to even think about supporting life as we probably am aware it. For correlation, by certain records, the most minimal temperature at any point recorded here on Earth is 97.8 degrees Celsius (144 degrees Fahrenheit). The temperature was recorded in a region of super-cold Antarctica that has never observed daylight. An endeavor to take here will pulverize our lungs and cause moment demise. 3rd planet Ogle TR56b lies in the Sagittarius star grouping 5,000 light-years from Earth. It is one of the hot Jupiters we discussed prior. Hot Jupiters are frequently shaped more remote in their heavenly frameworks and later draw nearer to the stars. Planet Ogle TR56b has just moved excessively near its own star. 8. It is close to such an extent that a year is 29 hours in length, and the exoplanet's surface temperature arrives at 2000 kelvins. Over yonder, the mists are not made of water yet of disintegrated iron. Downpour tumbles to the ground as hot fluid iron. 3rd planet Ogle TR56b lies in the Sagittarius star grouping 5,000 light-years from Earth. It is one of the hot Jupiters we discussed prior. Hot Jupiters are frequently shaped more remote in their heavenly frameworks and later draw nearer to the stars. Planet Ogle TR56b has just moved excessively near its own star. 8. It is close to such an extent that a year is 29. Third planet Ogle TR56b lies in the Sagittarius star grouping 5,000 light-years from Earth. It is one of the hot Jupiters we discussed prior. Hot Jupiters are frequently shaped more remote in their heavenly frameworks and later draw nearer to the stars. Planet Ogle TR56b has just moved excessively near its own star. 8. It is close to such an extent that a year is 29 hours in length, and the exoplanet's surface temperature arrives at 2000 kelvins. Over yonder, the mists are not made of water yet of disintegrated iron. Downpour tumbles to the ground as hot fluid iron. Second, deadly planets do not only exist outside our solar system. We have one lurking nearby, too. Without a doubt, Venus is the deadliest planet in our solar system thanks to its sulfur dioxide-rich clouds. Those clouds prevent useful sunlight from reaching the planet's surface and stop deadly carbon dioxide from leaving the atmosphere. The surface of Venus is filled with volcanoes that emit large amounts of heat and carbon dioxide. The large deposit of carbon dioxide makes Venus poisonous for humans. The thick clouds also trap heat and gas, making the planet lethally hot. Temperatures reach a hostile 467 degrees Celsius (872 degrees Fahrenheit). The hot temperature remains constant all over the planet, even at the poles. Other hot planets are often cooler at the poles. Venus also retains this high temperature every day of the year. Even the nights are as hot as the days. Researchers think that Venus would be similar to Mercury if Venus did not have these clouds. Interestingly, it also rains and snows on Venus, although things are quite different than what occurs on Earth. The snow is not made of liquid but of galena and bismuthinite metals. Rainfall is composed of deadly sulfuric acid. However, the high temperature on the planet means that rain never touches the ground. Instead, it evaporates midway to form another cloud. First, Proxima b looked promising when it was discovered. It orbits Proxima Centauri, a red dwarf star 4.24 light-years away from Earth. The exoplanet interested astronomers who thought that it had water and Earth-like properties. However, they soon discovered that they were wrong. Proxima b is so close to Proxima Centauri that the exoplanet completes an orbit in 11.2 days. It is also tidally locked, leaving one side deadly hot and the other fatally cold and frozen. Between the two is a middle ground that is more temperate. However, that region is unlikely to support life because of Proxima Centauri. As we mentioned earlier, Proxima Centauri is a red dwarf. One characteristic of such stars is their tendency to release solar flares every 2 to 3 months that strike the planets orbiting around the stars. Those flares would destroy the ozone layers of those planets, making them vulnerable to ultraviolet radiation from the stars. We observed one such event on March 24, 2017, when Proxima Centauri released a solar flare toward exoplanet Proxima b. The flare was so intense that the star became 1,000 times brighter within 10 seconds. Proxima b received 4,000 times the radiation that reaches the Earth from solar flares. That is bad for anything living on the exoplanet.